Welcome again, and hello everyone. My name is Kevin. Welcome to PyData Global 2021. I am your host. I am very happy to be here for moderate this session. Now, I would like to welcome Omri Fima, who is a data hacker, maker, and avid fan of Lego. Really interesting. He is a chief architect at Diagnostic Robotics, building AI and predictive analytics models to make healthcare better, cheaper, and more widely available. So Omri is going to present us components, workflow, and Cookbooks, building medical grade AI pipelines with Argo Workflows. So I'm going to pass it to you, Omri. Thank you very much.
Thanks, Kevin. So today I want to talk about building medical grade machine learning pipelines, but actually what I really want to talk about is about two things. I want to talk about machine learning pipelines and heart attacks. Now, why am I an expert about these two peculiar subjects? So first, I'm an architect at Diagnostic Robotics. I'm an engineer by profession. I'm not a data scientist, but after enough time working with data scientists, I probably can understand every second word that you say. And what we do at Diagnostic Robotics is we build something called AI-driven precision population health, which basically means that we can take patient data and medical and clinical data in order to create much more effective, much more efficient, and much more accurate and personalized treatment to people. And I will show you how it works in just a moment. So the way we do that, and actually the way our machine learning story started, is just probably like any other AI story with a notebook. And we had an experiment and we were asked to do something which goes sort of in the way of, okay, find me something I can do now to prevent hospitalizations from heart failures in 6 months from now. So we did our research and we took the data and we built a model and everything works. And congratulations, there's even a client who wants to use this model in production. Hey, and there's even a paper. So we can now get into production, right? Well, almost, not so quickly, because it all worked great when we're talking about that set of 300,000 patients. But when we're talking about 1 million or 20 million patients, working on notebooks is just not enough. And here comes MLOps. And MLOps might mean a lot of things. It might mean governance of data and managing your model artifacts and managing the lineage of data. But today I want to focus on one specific thing. I want to focus about pipelines, how to create your entire machine learning process a lot more efficient, a lot more predictable. And when we're thinking about it, pipeline orchestration is pretty much a solved problem, right? You just need to choose the tool that makes most sense to you, start to work with it. Most of them has great documentation, great examples out there, and start implementing your code as a pipeline and start running. And we specifically chose Argo. We love Argo. One of the reasons that we chose it is because it's Kubernetes native, it's API and CLI first, which is amazing for us as engineers. It has a really nice UI, and since it's Kubernetes first, it allows us to create robust deployments with Helm and Argo CD, which we are already familiar with. And that allows us to really create AI at scale, and that's a really small screenshot of how our pipeline looks like. It's much more complex than that. So great, excellent job. We now have a model in production that can work with the accuracy and robustness and the scale that we require. And now our product managers, our business people says, okay, that's a great job. Now do the same for long COVID. And I'm looking at my data scientists and data scientists looking at me and they're saying, oh dear, because while we were moving from experimentation to production, we've lost something in the journey. Because, pipeline orchestration should have solved the issue of creating robust machine learning pipelines, but they have introduced a lot of new complexities and new troubles. So yeah, data pipelines look really, really simple in the demo, but when you're actually trying to implement them on something, on a real world problem, on something a little bit more complex than this simple pipeline, it becomes a lot more complicated. And suddenly you're finding yourself managing a 3,000 line YAML files that nobody can navigate in, and everybody are afraid to edit and modify, which is not a great fun. Deployments becomes a lot more complicated because eventually what happens is that we don't have one version of our pipeline. Yeah, we have one version that we consider as our production, or maybe we have 2 or 3 versions, one for the old production, one is a candidate for production. But we need to support a lot of other versions of the pipelines to support our research approaches. And we need to make sure that our experimental pipelines do not override or do not damage our production-grade pipelines, and that different pipelines from different users don't override one each other. And that becomes a little bit more complex. Another thing that we found is troublesome is that iterative experimentation became slow. So now when I want to work with pipelines, every time I want to change something and give it a try, I need to change, push a branch, wait for the Docker image to be built, push it into our Kubernetes cluster, and then go to the Argo UI and run my pipeline, which is nice, but a lot slower than running your just clicking something, writing a line of code, and just clicking Shift Enter and seeing it work in real time. And that brought us to some understanding regarding the duality of research cycles. When we are talking about machine learning processes, we're actually talking about 2 different modes that we're working in. One is the research mode, when we need to be fast, experimental. We need to be adjustable and iterative, and where the data scientist is the king. And there is the development mode, when we require scalability, when we require reliability, governance, and robustness. When we want our pipelines to run reliably in a fire and forget mode. This is where engineering is king. And the issue is that they're not the same tools are used to work on research mode and development mode. But the issue with medical pipelines is that we don't only have these 2 modes, distinct modes. When we're talking about the exploration and development, it's actually a spectrum. So on one hand, we have the production grade product, which actually influences people's lives. So we better not screw that up. And there is the exploration on one other hand, which there aren't too many rules or regulations. But as we go more and more into production, there are a few steps that are still experimental. For example, clinical validation or prospective research, where we actually influence people's lives. We need to be able to react on the other end, but we still need some type of governance. We need to make sure that our processes are reliable and can run on a production grade once we decide to promote them. So MLOps add complexity, and it can hinder our ability to do experimentation. So what I want to talk with you today is how to solve that. And the solution is surprisingly not in more tool or changing your tools. The solution is, or a lot of it, is in architecture. So this talk today is going to be about our journey from research to production and back up again to research. So there are 4 steps that we found out to be very effective in order to make our, or to fix this gap between production and research. So the first step is to Pythonize our pipelines. Basically, we took this YAML and we've created a very thin wrapper built on Python. And with this wrapper, we're building our pipelines in Python and then compile it back to YAML. There are actually several ways to do that. And the neat part here is that, yeah, this code is relatively familiar. We understand how to work with it. So this is an example of a very simple pipeline where we say, okay, we want to run an hello from a very basic container. So we just put our input params and we can just set it up and run what you need to run. And then we can just compile it or send it directly into Argo, or compile it and then send it into our deployment pipeline. We even have utilities to run it out of a command line, which is really nice. So what are the benefits of Pythonizing the DAG? So one aspect, it's very developer friendly and very data scientist friendly. It's create a single source of truth of what a pipeline should look like. It has all the great things that we have in code. So for example, autocomplete, schema validation, tests, linting, opinionated APIs, and scaffolds we can build upon it. And that's probably the most important aspect of it. The ability to create abstractions over the basic language of our pipelines, something that is very hard to do once we're talking in YAMLs, and very easy to do. It's basically what we do every day once we start to talk in code. There are several ways to do that. There's the Kubeflow pipeline compiler, there's Cooler, and there's PyArgo DSO. It allows you to do that. We chose just to just build Python files or Python schemas out of the original Argo DSO schemas, and I'll show how you can do that later. And the really neat part is that once you treat pipelines as compilable code, it's easy to bring engineering practices and patterns. For example, let's have a look on this basic pipeline and how we've changed it in order to bring abstraction into the game. So a lot of time our engineers or data scientists don't really care about the image and resources and a lot of aspects which are, let's call it technical aspects, and not part of their daily business life. So what we're trying to do, like you're seeing in line 1, we took all of this and abstracted it out and into a very nice name, and we just import it and use it. And what we get for free is that we get a very opinionated API that explains how to use it, which makes us life a lot easier and allows us to define things, for example, as resources, which are basically the Kubernetes resources that we might need. And when you ask a data scientist what Kubernetes resources you might need, they might look at you a little bit strange. And here we've just gave them some sort of a business or domain name, which makes things a lot more easier instead of, yeah, give me a 4 CPU, 64 gigabyte machine. No, there is an app machine that works for very small things. That's what you need. The second aspect, once you've Pythonized your code, Pythonized your pipeline, we can now talk about pipeline architectures. And to talk about pipeline architecture, I want to talk a little bit about something else, about hamburgers, specifically in-and-out burgers. If you're not aware of in-and-out, in-and-out is a chain of a fast food chain from the West Coast. And what they became famous of is their secret menu. Basically, you can order a list of very crazy dishes from the protein style, which replaces the buns in lettuce, or the 4-and-4 animal style, which hides somewhere over here. And the neat part when you look about how In-N-Out Burger secret menu works is that they give you a lot of possibilities to customize, but they're doing it with the same 7 or 8 ingredients that they can source in a very efficient, very consistent, and very high quality way. So when they're talking about ingredients, there's a very limited set of ingredients that they are making sure that they do right. But when there is the choice of combining these ingredients together, they're giving it a choice to combine it as you wish. And if we're talking about heart attacks, and I've promised you machine learning pipelines and heart attacks, so yeah, sometimes these combinations make sense, and in this case, probably they don't make sense, but it's your work as a customer to decide. It's your job to decide if it makes sense or not to your particular case, probably. So we took the in and out secret menu concept into the way we build or manage our pipeline assets. And we were splitting our pipelines into 3 different types of components. One is a component. A component is a reusable piece of code and pattern that we can use to abstract out things that our data scientists and data engineers are not really interested in. And I'll show you an example in a moment. Another element is workflows. Workflows are reusable atomic pieces of work. They can be consumed independently or as part of a larger cookbook. And the idea behind that is that workflows are closely managed, are closely curated. And basically, we make sure that our workflows always work at the highest level and highest quality possible. And now we have cookbooks. Cookbooks are basically menus. It's a combination of one or more workflows or even other cookbooks tailored for a very specific task. So their lifetime might be limited, so we might use them for an experiment, and feel free to just delete them after they leave their usefulness. So let's talk about components, see a little bit how they work. So components in our basic might be things that you might want to abstract from users, for example, Kubernetes resource management, configuration injection, how you handle secrets, how you handle common environment settings and things like that. There might be common templates that will help you create a more opinionated pipelines and make your developer life a lot easier. And there might be scaffolds that will help you to develop things a lot quicker. So here's a quick example of how such component look like. So that's a component that defines our ETL machine, which with memory has, and one neat things that that we've added that in debug mode, we can actually reduce the amount of memory, so we can actually run it on a smaller machine when we're trying to compile the same pipeline once for debug environment and once for the production environment. Another element is configuring secrets, which again, that's a lot of code. Most of the data engineers and data scientists are not interested in that. We can abstract it out and just reference it in our pipelines very easily. So this can be managed by our DevOps team instead of wasting time of everyone. Workflows are basically the workflows, the basic Python workflows that we've seen before. What makes workflow is it has 2 things. It has the entry point that defines all the steps, or basically the DAG that is required from the workflow, and the arguments that are needed in order to run it independently. Now, in these steps, one of the nice things when you're designing workflows like that is that in a very quick glance, you can understand the dependencies of a workflow. You can understand that compute feature and target template is dependent on all of these targets, and which makes things a lot easier. And of course, it makes a lot easier. Things are very much easier when you're trying to have a look on a much more complex workflow. So cookbooks basically are a collection of these highly curated workflows that we've built before, and maybe we might add some ad hoc workflows that we're just building for some experiments and connecting them all together into some sort of a business flow that makes sense. So we can take all of these cookbooks and create, let's say, a full process that trains and serves a new model, or we can modify it into a process that trains and serves multiple models into one hybrid model. Or even if we want to work on an experimentation mode, yeah, we can just push inside an ad hoc workflow for sampling data, and then we can create something that allows us to work with that. Or if we wish to to run our pipelines in a testing environment or in an end-to-end test, we can wrap this workflow in another end-to-end workflow that is responsible just to create a test context, run the previous cookbook, the previous cookbook, and then do some validation and test cleanup to make sure that eventually this entire cookbook works properly. The way we organize it in our code base is we're actually splitting our code into these areas of components, which are the curated collection of our shareable ingredients, our workflows, which are shareable, reliable, and consistent building blocks, and cookbooks, which again are mix and match of curated pipelines that can be different from the environment to environment and developer to developer. So once we talked about how we're building our pipelines, let's talk about how we're deploying them. So we have a cookbook menu that we can just access from our UI. And again, one of the issues that we're having is, okay, so I want to make a small modification in our cookbook. How do I deploy it? Yeah, probably the most trivial way to do that is just add a prefix, and then you end up with a lot of junk cookbooks that you need to somehow find if they're overridden something or destroyed something else or need to be deleted or maintained. And we don't want to do that. So one thing we did is to leverage the ability of Argo to do namespace isolation for pipelines. Basically, we connect our cookbooks and our branches into different namespaces. So once we do git push to our Git with new pipelines, these pipelines are getting built and deployed automatically to a dedicated namespace. And then if I'm working on an experimental branch, I can make sure that all of the pipelines that I need to work with are already there waiting for me and are deployed automatically. If I'm working on a production branch, I know that my pipelines are isolated from any other experimental branches that might be there. Our pipeline is working on Argo CD, and it's a pretty much standard CI/CD process that allows us to deploy all of our pipelines just as Kubernetes code. The fourth step that I want to talk with you is about experimentation. And the question here is that I'm getting asked a lot from data scientists in my team. Yeah, so sometimes I want to use their existing pipelines, which are very robust, and that's a good thing for me. But sometimes somewhere in the middle, I want to do some wibbly-wobbly, timey-wimey work and get some result and then continue the pipeline from there. So how can you support this type of workflow where this step should be very interactive? And the problem is that the experience is very fragmented. If I want to do that, I need to request from my data scientist to run part of the workflow from the UI and then return back to the API and then go back to the UI and so on and so on. And the solution that we've built for that is notebook integrations. We've actually built a client for notebooks for Python, which is very nice to use, which allows us to submit Argo workflows with their parameters from a notebook, wait for results and access the results, even if they are artifact results which are served on S3. You can install it today using pip install Argo Workflow tools, or contribute to our GitHub. Some of the nice things that you can do with it. So of course you can submit a workflow, which is really nice. If you wish, you can suspend your workflow, work with it manually or interactively, and then resume it once you feel comfortable. You can retry a workflow if it makes sense or if it failed. And of course, you can access to the workflow outputs when needed. And the really neat part is that you can actually write your own custom cookbook using the previous Python code and just compile it and run it ad hoc through your Jupyter Notebook without actually making any deployment work or anything like that. So you can actually enjoy both of the worlds, working with high scale Argo workflow and just doing things interactively. So the key takeaway from today. So one important aspect, before you even start thinking about how to create an architecture for your workflow, understand that duality between research and development. Understand what it means for you and how you can transform between these two modes. One aspect that helped us mitigate this duality is to treat our pipelines as code, is to think about pipeline architecture, because once we work with code, we can talk about architecture and abstraction. Think really well about deployments and think really well about how we combine these interactive and high-scale, robust pipelines. So thank you very much, everyone. If you wish to contact me, you can find me at Omri Fima at Diagnostic Robotics, or you can post issues or requests on our GitHub, where you will find all the libraries I've talked about, and we might add in the future examples of how to use it. And of course, you can talk with me on the Slack channel that was open for this purpose, components, workflows, and cookbooks. So thanks, everyone.
Thank you very much, Omri. Okay, I think actually time is over. So if anyone has a question, please don't forget to reach out Omri to the Slack channel or the gather.town, okay? So please, I would like to thank you for being part of PyData Global 2021, Omri. Thank you very much. Really interesting.
Thank you very much.